We are going to discuss about number system, what is an IP version 4 address, what is subnetting, and what is a regional registry, internet registry. So what is a number system? A number system is a mathematical language using specific symbols, digits and rules to consistently represent and express quantities and numbers. So what are those symbols? Basically they are digits. So what is the basic number system that we follow in our day-to-day life? That we follow decimal number system. So decimal number system has 10 numbers from 0 to 9. That's why the base is 10. So what defines the base of a number system? The number of digits in that system forms the base of that system. So if if you have a binary system, the number of digits in that system is 2, 0 and 1. If you want to find how many numbers that system has, you will have to subtract 1 from the base. 10 minus 1 basically 9, so 0 to 9. 2 minus 1 is basically 1, so 0 to 1. So each number you will have to start from 0. Similarly, we have another system called hexadecimal system. So the base is 16. So how many numbers it will have? 16 minus 1, that is equal to 15. So 0 to 15. There are other systems also like octal system with the base of 8. You can also create your own system. Okay, now you know how to create your own system, right? Just follow the procedure. But in the networking field, you should know decimal system, binary system, and hexadecimal system. So let's proceed. Now you should also know how to convert from decimal to binary. Basically, to convert from decimal to binary, you will have to divide a number consistently by 2 and keep recording the remainders, like this we have done. And at the end, we bunch the last quotient along with all the remainders at each step. So you see, like 49 is represented by 1101. Similarly, 57 is represented by 110001. So for 49, you keep dividing by 2. So you keep recording the quotient and remainder at each step till you get 1 as a quotient at the end. And then you group the last, so you should at least get 0 or 1 at the end. Then you, along with the last quotient, you group all the remainders and you will get the final answer. Similarly for 57. If you want to convert decimal to hexadecimal, what you will do? What is the base of that system? 16. So instead of 2, you will use 16 to divide that number. And you will follow the same procedure. Just like so, 312 is represented as 0x138. 57 is represented as 0x404. So x means the number that you are representing is in hexadecimal system. Similarly, for binary, sometimes you will see B, 0B. So that is a binary system. Now you understood how to convert from decimal to binary and decimal to hexadecimal. So you should also understand how to do the reverse from hexadecimal to decimal. For decimal to binary or from decimal to hexadecimal, you need to divide using the base of that system, 2 and 16 respectively. So for reverse, you will have to multiply. Correct? So this is how you multiply. You put down the number as you see in the diagram. Put down the number in binary as like this, and then below each number you write 2, the base of that system. And from right to left, you keep on incrementing the exponential of 2, and then you multiply each number with the 2 exponential, and you add it. So 28 is represented as 11100, and 113 is represented as 01101. So this is binary to decimal conversion. Same procedure for binary for hexadecimal to decimal conversion, provided the base of the system is 16. So here is the example. So A0F is represented as 2575. 3F1A is represented as 16154. In hexadecimal system, 10 to 15 is denoted as A2F. 0 to 9 is 5 as is, but from 10 to 15 it is denoted as A to F, A, B, C, D, E, F. Okay, that's why 16154 is represented as 3F1A. 0, okay, 0x3f1a. Now let's understand IP addresses and private standard subnets. So basically, what is an IP address? IP address is a 32-bit unique address. So IP address is divided into 4 octets. Each octet is of 8 bits. So here you see 10.0.0.0. This is a subnet, but this is how the IP address will look like. So so these are the octets. Each octet is of 8 bits. So internet is a IP address is a 32-bit unique address. Now in IP version 4, you have a private IP address range and a public IP address range. So it is defined by RFC 1918. So what is the range of the private IP address? 10.0.0/8, 172.16.0.0/12 and 192.168.0.0/16. So this private IP address range, what do you mean by private IP address? The IP address that you can use in your corporate network or in your private network. But these IP addresses are not routable on the internet. So if you want to host a web service on the internet, you require a public IP address or real IP address. So any IP address other than this are the real IP addresses. So these 3 ranges are called Class A, Class B and Class C. Apart from Class A, Class B and Class C, also there is Class D and Class E, which is used for multicasting. But we will discuss it in a different session. But other than these 3 IP addresses and the multicast addresses, other IP addresses are the real IP addresses, and it can be used for hosting your web services, or those IP addresses are routable over the internet. So Class A is with 8 subnet masks, Class B is with 16 subnet masks, and Class C is with 24 subnet masks /24 subnet masks. These are the 3 types of standard classes. Okay. Now if you want your private subnet to access the internet, you require a device which can convert this private IP address into the real IP address. As I told you, if you want to access anything on the internet, you have to reach your IP. You should be able to reach that device, right, which is exposed on the internet. But that device will have a real IP address. So if you want to reach to that real IP address, your IP should get converted into a real IP address. That conversion is called as NATing. Okay, and it is done by a router or a device which is capable of doing NAT. So if it's a cloud based, it can be a NAT gateway also, which is used to translate private IP address to public IP address. Now what is a CIDR? What is a classless inter-domain routing? So basically classless means what? You are given a class A, like with a /8 subnet mask. Okay, but it's a supernet. It's a big chunk of a subnet. Okay, so for efficient utilization of that big chunk, what you will do, you will divide it into a different subnets. How you divide it into different subnet? By increasing the length of the subnet. So when you say class A means the subnet mask is /8. So when you increase the subnet mask of the class A, it can be /10, it can be /12, /14, whatever. Okay, so basically you are increasing the length of the subnet mask. So it won't be a standard class A. That's why we call it as, now it is a classless. Now it is not following a typical class. It's a classless. Okay, and because you are changing the length of the subnet mask, that's why it is called as variable length subnet masking. Now why you use the word masking? Because you from the host portion of the subnet mask, you borrow a bit and you mask it. You mask a 0 with a 1. That's why it is called as variable length subnet masking. Okay, so CIDR is nothing but a supernet, a big chunk of your subnet, which is a method for assigning IP address. Okay, that will improve the efficiency of address distribution and routing on the internet by allowing for flexible and variable length subnet masking. So if you are going to start a new business of a service provider, you will approach to an internet registry, okay, and they will provide you a big chunk of 1.0.0/8, okay, and then you will create further subnets from that big chunk and you will assign it to your customers. So those subnets are different networks, okay, they are having different classes. They are not a standard class A, class B or class C. It can be of for different subnet mask. So you cannot specifically classify it as a class A or class B. Okay, so that's why it is called classless. And because you are changing the subnet mask, that's why it is variable length subnet masking. Now, that's what I have given an example. Provider is given a big subnet, for example 1.0.0.0/8. Then this is what we call a CIDR. Now the provider has to break this supernet into small networks. Okay, so subnetting is breaking a supernet into a small chunks of subnet, and supernetting is creating a bigger subnet from multiple subnets. Okay, vice versa. Now, what is the regional internet registry? As I told you, if you want to start a business of a internet provider, you will require a real IP addresses, a chunk of real IP addresses, a block of real IP addresses. Who will you approach? You will approach to regional internet registry. So in every region, like in Asia Pacific, in Europe, in Middle East, in Latin America, in Caribbean, in US, in Central, everywhere you have an authority, okay, whose job is to manage and allocate internet number resources such as IP addresses and autonomous system numbers within a specific geographic region. So you can see those internet registry: AFRINIC, APNIC, ARIN, LACNIC and RIPE. These are the several regional internet registry in different regions. Now you have understood what is an IP address, right? It's a 32-bit IP address and having 4 octets. So each octet is of 8-bit. So what is that IP address consist of? That IP address is mainly made of 2 portions, network portion and the host portion. So when you say /24, so basically what you are saying, 24 bits of that subnet are standard or are constant. Of the 24 bit of that subnet mask are constant and they are all on. That means they are all ones. So 24 bits are all ones. Remember this. When you say /24 subnet mask, that means that's the 24 bits, the starting 24 bits of that subnet mask are all ones. Now, what is the size of the IP address? 32 bits. So out of that 32 bits, 24 bits are all on, or are all are ones. So how many bits are remaining? 8. So they are the host portion. So they are all zeros. Now, so you can consider this 192.168.3.0/24 as a CIDR block, okay, a private IP address CIDR block. Now, if you are working for an organization, okay, and suppose there are several departments like HR department, financial department, okay, similarly other departments, and you want to have different subnets for each department. So what you will do? Your manager will give you this block, say, okay, or manager, or maybe the one who is managing the IP addresses, he will provide you this block of IP address or CIDR block, and he will tell you, okay, you break it into a different subnet as per your requirement and use it. Now you are assigned a task to break this subnet into a smaller subnets. So how do you break it? So he has given you a /24 subnet mask. So remember, he has given you a /24 subnet mask. That means initial 24 bits are on. You cannot fiddle with those 24 bits. Okay, it means that when you say /24 bit subnet mask, means the first 24 bits are on and you cannot do anything about those bits. Now the remaining 8 bits, the host portion, those are the bits which you can play with. to create your subnets. So if you want to create two subnets, correct? If you want to create two subnets or three subnets, according to your requirement, you will mask the bit of the host portion. You will mask the number of zeros into 1. That's why it is called as variable length, VLSM, variable length subnet masking. So you will mask 1 0 as 1. Okay. So now what will happen, that subnet mask will change to from 24 to 25. The resultant net subnet will have a subnet mask of 25 because you have borrowed 1 bit from the host portion to 25, and the remaining bits and the remaining 7 bits belong to the host portion. Correct? So the first subnet from 3.0, the first subnet will become 192.168.3.0/25, and the other subnet will become 192.168.3.128/25. Okay. Now, what is the formula to calculate how many number of subnets it can be created from using after doing the subnet after changing the subnet mask? What is the formula? How you will calculate? How will you calculate there are two subnets or three subnets? So it depends upon the number of bits that you mask. If you want to calculate the number of subnets, you must know how many bits you have masked. Here you have masked 1 bit. Okay, to make it /25, you have masked 1 bit. So the calculation is total number of subnets will be equal to 2 raised to number of bit borrowed from the host or masked. So for us it will be 2 raised to 1 equal to 2 subnets. So there will be 2 subnets, 3.0 and 3.128. And how to calculate the number of hosts in each subnet? So basically again it is 2 raised to n. 2 raised to n, where n is number of remaining host bits. So this will give you 2 raised to 7, that is equal to 128. So each subnet will have 128 IP addresses. But out of that 128, 2 IP addresses will be unusable. You cannot use those 2 IP addresses. What are those 2 IP addresses? One will be a network IP and the other will be the broadcast IP. The remaining 126 IP you can use. So from 3.0, as I said, it's now you have converted this /24 into /24 subnet mask into /25. So there are 2 subnets and each subnet will have 128 bits, right? So how will you calculate? How do you find which are these? So 3.0, it will start from 3.0, it will end in 3.127 because it has 128 IP addresses. So the first 2 IP addresses cannot be used. So usable IP addresses are 3.1 to 3.26. So next subnet will start at 3.128. It will go on till 3.255. So again here the first IP and the last IP cannot be used. So the usable IP hosts are 3.129 and 3.255. Understood? This is how you do the subnetting. Okay. So 3.0/24 was your original subnet. Okay. It was a single subnet and the host portion was carrying 8 bits. So 8 bits means 250 per usable host were there. Why not 255, 256? 2 raised to 8 is equal to 2 raised to 56, right? 2 raised to 8 is equal to 256. But you have to minus 2. You have to subtract 2 from that 256. Why? For network IP and broadcast. So the resultant usable hosts were 254. But you were asked to create 2 subnets. How did you create 2 subnets? You borrowed 1 bit from the host portion. You masked 1 bit from that host portion. So 2 raised to n. 2 raised to number of bits borrowed from the host portion. Here it is 1. So 2 raised to 1 is equal to 2. So 2 subnets. How many hosts per subnet? 2 raised to number of host bits. 2 raised to 7. That will be equal to 128. But we have to subtract 2 from that to find out number of usable hosts. that will be 126. So this is how it is. Okay. Okay. So this is, I have given another example here, 172.16.0.0/16. So here you have a bigger subnet of 16 subnet mask. So original subnet was having 16 bit of network portion and 16 bit of host portion. So it is a big subnet mask, correct? So now, so number of usable hosts were 2 raised to 16 minus 2. Now you have been given a task to convert it, create a subnet of /22. So /22, already you have a 16 bit which are already on. 16 bits are already on. So you will have to add +6. So +6, you will add +6 bits. So the total number of subnets 2 raised to number of bits borrowed from the host portion. So 2 raised to 6, that will be 64 subnets, and total number of hosts will be 2 raised to number of bits in the host. So that is 2 raised to 10. But you have to subtract -2 to get total number of usable host IPs. So that will be equal to 1022 in each subnet. So this is how you do the subnetting. So I believe that is the end of the subnetting session. I hope you enjoyed this session. Please subscribe and like my channel for more useful information like this. Thank you. Bye.